All right, the final proof by induction. This time we're going to look at proof by induction for inequalities. And this can actually be a little bit tricky. I found it a little bit tricky. So prove using mathematical induction that 3 to the n is greater than n to the 3 for all natural numbers greater than or equal to 4. So what we want to do, again, as we've been doing, outline the proposition. Let P of n be the proposition that 3 to the n is greater than n to the 3 for n greater than or equal to 4. We're talking about natural numbers here. And then what we need to do is need to show that the base case is true. So show that P of 1 is true. So we're going to get the left-hand side is P of 4. Now remember, the minimum value of n is 4. So our base case here is actually 4, not like at 1, like some of the other inductions we've done. There's going to be 3 to the 4, which is 81, I think. I didn't actually check that. I think that's right. And 4 to the 3, which is 64. So it is indeed the case that the left-hand side is greater than the right-hand side for that base case. So the base case is true. Okay, then we move on to our next step, which is to assume that K is true. So assume that P of K is true for some K element of real numbers, but this time K has to be greater than or equal to 4. So basically that's just restating this. It's going to be 3 to the K is greater than K to the 3. And then what we need to do now, which is obviously the trickiest step, is show that P of K plus 1 is true. And this is the part I found a little bit challenging, but I think we can make some sense of it. So basically what we're going to do is we're going to take this step here, and we're going to say, all right, now we're going to the K plus 1 term. So replace any K's with K plus 1. So you get 3 to the K plus 1 has to be greater than K plus 1 cubed. Okay, and then the sort of working out from here can be a little bit tricky. Let's just do purely thinking about the left-hand side. And I'm just going to show you it all in one hit and we'll step through it. We know that the left-hand side is 3 to the power of K plus 1. What we're going to do first, though, is just going to make a note about what the right-hand side is. I think you would agree, if you expanded the right-hand side, you would get K plus 1 all cubed, which is K cubed plus 3K squared plus 3K plus 1. Just expanding a cubic there. And so what we need to do is we need to show that 3 to the K plus 1 is greater than this, right? And this was a bit new to me in terms of how we do it, but we're just going to purely thinking about the left-hand side, and then we're just going to make some claims that will then show that this is true. So 3 to the K plus 1, just by applying the index laws here, I think you would agree that you would get 3 multiplied by 3 to the K. Remember, index laws say that if you've got the same base, you add the powers. So in this case, we're sort of doing that index law in reverse. Okay, and then sort of invoking this fact that we're assuming here, we know that 3 to the K is greater than K cubed. So 3 times 3 to the K must be greater than 3 by K cubed. Essentially, you just multiply both sides of this by 3, right? So this, yeah, the left-hand side, yeah, is greater than 3 times K cubed. Okay, but we know as well that 3 times K cubed is K cubed plus K cubed plus K cubed. Okay, and this is where it gets a little bit tricky. What we're going to say from here is, well, let's just think about these terms and think of terms that we know would be smaller if K is greater than or equal to 4. I think you would agree that 3K squared and 3K squared would be smaller terms than K cubed if K is greater than or equal to 4. And I'm just thinking in my head if that's some sort of circular reasoning, but I don't think so. I think that holds true, and I think that's should make sense. We know that, yeah, this has to be greater than K cubed plus 3K squared plus 3K squared. Now you're probably wondering why I picked that, and I was wondering that as well, but we're just trying to sort of make it match this right-hand side, because then we can show that the left-hand side is greater than the right-hand side. Okay, and then what we can say is, right, we know that this thing must be greater than something, or actually, we should say first, this thing is equal to K cubed plus 3K squared plus K squared plus K squared plus K squared. We're just breaking this last term up into K squareds. But we know that that now must be greater than K cubed plus 3K squared plus 3K plus 1, because we're reducing the powers in the terms on the left-hand side. So what we can say in the end is, all right, well, the left-hand side, which was 3 to the k plus 1, is greater than k cubed plus 3k squared plus 3k plus 1, which is the right-hand side. So we've shown that the left-hand side is greater than the right-hand side. I found it a little bit tricky to wrap my head around just in terms of the working out, but it is what it is. Hopefully that made some sense. It's essentially just breaking the terms up to make the inequality stronger as you go. And so what we can say is therefore that P of k plus 1 is true, and hence we've shown that P of k implies P of k plus 1 for all natural numbers k greater than or equal to 4. And so this whole process was mathematic induction, and we've shown that P of n is true for any natural number n where n is greater than or equal to 4. That's sort of our conclusion. Okay, I cannot resist graphing it just to sort of get an idea of what's going on here. In red, we've kind of got 3 to the n or 3 to the x just because we're on the xy plane. And then we've got n to the 3 here or x cubed in blue. And you can see that these graphs cross over twice. They cross over once at about 2.47 and another time at 3. But we can certainly say for sure that the red line is greater than the blue line when k is greater than 4. So that's there somewhere. And the red line will forever be greater than the blue line when k is greater than 4, and then 5, and then 6, and so on. All natural numbers up to infinity. Okay, hopefully you found that useful. As always, if you're finding any of this even a tiny bit useful, please consider giving it a like or subscribing. As always, if you have any questions, please let me know and reach out. Happy to chat and answer any questions you've got. And I'll talk to you soon.